these, and we passed in sum as a variable into a function called add these, just like this. What's going to happen is the value of sum, so let's say we have an integer here, integer sum is equal to 5, and we pass sum into the add these function. Well, if we change the value of sum and we do not pass it back, sum is still going to be equal to 5 because we are passing a value. With the reference operator and with pointers in general, what we're going to be able to do instead is pass by reference, and any change that is made inside of there is going to show. Now, a pointer is going to be able to store a memory address. Let's recreate my age to demonstrate this. And whenever you're defining a pointer, you just have to use the same data type followed by a star, and we'll say age pointer like this is equal to, and then you're going to use the reference operator to pass that over. Just like before, we're going to be able to access the memory address with this pointer of pointer by just typing in age ptr, but we'll also be able to dereference to get the data at that memory address. So we'll say data at memory address. And how you dereference is to put the star in front of age pointer, right like that. You'll see here with this pointer, we'll now be able to get the memory address as well as the data that is stored at that memory address. Let's take a look at arrays as well. Let's say we have our bad numbers array, just like we used previously. We can then go int star to create a pointer, and we'll call this number array pointer is equal to bad nums. What's neat here is we're going to actually be able to increment through our array just using shorthand notation like plus plus and minus minus. So we can go cout address number array pointer and value, and then to get the actual value in the array we can go num array pointer and then close that off, and then come in and go num array pointer plus plus to get the next value in our array. Bounce that in there, and there you can see, jumped in there, grabbed 4 and 13 as well as the memory addresses, and as we saw previously, an integer takes up 4 bytes. You can see the difference in the memory addresses right there. So you're learning about how this stuff is stored inside of here. And something else that is interesting is an array name is just a pointer to the array. So we could come in and go address and put the array name by itself inside of there, bad nums, to get the value that's stored there, and you can see that it works also. See, same memory address, same value. So something interesting to think about. Now, like I said previously, whenever we pass a variable to a function, you're passing by value. However, whenever you pass a pointer to a function, you're actually passing a reference that can be changed. So let's jump up here and let's create a function to demonstrate exactly how this works. This isn't going to return anything, so I'm going to put a void inside of there, and I'm going to say make me young. And this is going to receive a pointer. So I'm going to put int with a star after it, and then age like that. And then let's pop out here on the screen the previous age. I used to be like that. And to get the value of age, I put a star and age, because otherwise it's a memory address. Have to put that star in there. But then I can also go in and change that value by putting star and age is equal to 21. Don't return anything, don't have to do anything otherwise. Then I can come down here and call make me young. And if I want to pass a reference to that guy, passing by reference, that's all that means. I can do that, and then I could put I'm, and then just to check or verify that it actually changed that age, I can do this, and you can see. I used to be 39, that came from the function, then we changed it to 21 inside of the function, and then you can see here that it changed globally. You can also come in here, and once again this ampersand is going to denote that age reference will be a reference to the assigned variable. So there's a reference, the difference between a reference and a pointer, which I'm going to get more into when you should use one and when you should use another one. Then we're going to be able to go cout. You're actually going to use references more than you use pointers. Like I said, that's coming in a second. Another thing that's interesting is we could take this reference and increment it and see that that also changed my age, right like this. You can see, here's my age at 21, here's my age at 22. Again, globally, we're changing all of those. Then let's create another function. This one's going to be called ActYourAge, just to pass the reference and show the difference between passing that reference and dealing with pointers. Come up here and create another function. It's also not going to return anything, just to prove that nothing's exchanging hands. ActYourAge, except we're passing a reference this time, so we're going to put the ampersand inside of there, and I'm just going to put age there again. Doesn't matter what I put. And then here I'm just going to say age is equal to 39. Come back down here again, just demonstrating the difference between passing by reference and passing by pointer. And we could go in and prove that it still changed. Age is equal to NL. And there you can see it did indeed change. So basically you might ask yourself, well, whenever you're deciding whether you want to use pointers or references, when should you use which? Well, basically you should use pointers if you don't want to have to initialize at declaration. What that means is, you can see right here, I am defining or initializing what I'm referencing whenever I am using the reference option. Whenever I am dealing with pointers, I do not need to immediately initialize. And then on top of that, with a pointer, I'm going to be able to assign another variable to it. So a pointer is going to be able to deal with more than one, while a reference is going to get this one reference to this one variable and be stuck with it. So if you don't need to be able to change whatever you're going to be pointing at, use a reference. That's pretty much the ironclad rule. And that's the basis of pointers. We're going to get more into them here in a second, but now I'm going to jump over and talk about classes now. Now, in object-oriented programming, what we're trying to do is model real-world objects like an animal in code. And how you do that is you think about, well, what makes a specific object an object? Well, each object has attributes such as height and weight and whatever, and it also has capabilities. So it can run and it can eat, just to be really simple there. Well, these attributes are going to be modeled in the variables, and these capabilities are going to be modeled in the functions or the methods. Same thing, just a different name. So what I'm going to do here inside of my class is I'm going to have some of these things be private. And by private, what I'm saying is that anything that is marked private in regards to attributes or variables is only going to be able to be changed by functions inside of my class. And we do that just to keep them protected. And this is called encapsulation. So I'm going to have my name, height, and weight all be private. And while I'm in here, I might as well talk about static variables. Basically, if you put static in front of something, all that means is that this variable's value is going to be shared by every object of type animal that is ever created. So let's say that I want to also keep track of the number of animals that are created from my class. Well, it wouldn't make sense that an animal would count. That's another reason why we have static here, because static variables also normally are attributes that the class object would not have. So we want to be able to count the number of animals that are created, but we do not want to actually have the animal type defined to be able to do it. And that brings us to public. Well, if we have variables that are private, we're going to have public methods that are going to be able to access the values inside of there. So we're going to have something like get height. There we go. And I'm actually going to just create this here on one line. And whenever this is called, it is going to return the value that is stored for my animal object to whoever calls for it. And we could also do the same thing with weight. And this is also encapsulation. We're keeping all of our data protected. And this is going to return a string whenever the get name function is called. And we can just go return and name, and there we go. But what we really want to do whenever we're dealing with encapsulation is protect the values that are going to be stored. So they might want to come in here and set the height, and let's say that we decide that we only want them to be able to enter a reasonable height. We could provide a check inside of here to verify that the animal height makes sense, and otherwise discard it. But in this situation, I'll just keep this nice and simple. Also going to do exactly the same thing here for the weight. So weight, and let's have this be kilograms, weight, kilograms, and of course it doesn't matter if you put centimeters or kilograms or what you put inside of there. And set name, and we'll say animal name. Right now we have to have this be different from this, but I'm going to show you how to change that here in a second. Animal name right there, and everything else looks perfectly fine. And then we could also create another function inside of here. Let's call this set all. And here we're creating a prototype of a function that we are going to declare here in a second. You're going to see it. And that's how we declare a prototype. Another thing we would want to have is a constructor. And what a constructor is, first off, its name is going to start with whatever the class's name is. And then here we're going to create a prototype of that. And this is going to be the function that is going to be called whenever an object is created. And so it'll pass in the height, the weight, and the name, and the constructor is going to handle creating every object. If we have a constructor, we also should have a destructor, and it just has that little tilde sign there. Once again, this is going to be a prototype where I'm going to build or declare the actual one down below. And then let's say that we want to have another constructor that doesn't receive anything. And this is an example of overloading. And to overload a function, like I talked about previously, the name can be the same, but the attributes need to be different. So here we have 2 ints and a string. Here we are getting past nothing. There's also protected members. Whenever we're dealing with protected, what we're saying is that anything marked as protected is going to be available to members of the same class as well as subclasses, but nothing else. And we could also come in here and define a static method, and a static method is set aside because they are attached to the class and not to the object. As you're going to see, I'm going to show you in a second how to actually call for a static method. And in this situation, static methods also can only access static member variables, like this guy we have up here, right there. So we are going to have this method specifically be able to return the number of animals that are created. Here we go, and this time we're not going to do a prototype, we'll just have it actually do what it's supposed to do. There it is. And also finally we'll create a toString, which is going to print out all the information we have on our animals. Okay, so we went and we declared our class. After this little curly bracket, we're going to put a semicolon, and now we're going to declare everything. So the very first thing we're going to declare is our static number of animals, and how we refer to static variables is put the class name followed by these 2 colons right here, and then whatever the name of it is. Say it's tied to the class. It has absolutely nothing to do with the object itself. We can then define the prototype method for setAll. So setAll is right here. We're going to go and define it. There, that was just a prototype, and we're going to do that by putting void animal and then set all, like that. And then we have to define exactly what's being passed in here. So we're going to have 2 ints for the height and the weight, as well as the string name. This basically does what the constructor does, but just wanted to show you something. Now, if you want to refer to an object-specific height and not just a generic type of height, you put this inside of here. And the reason we have to do that is whenever the class is created, there are no animal objects created. So if we want to refer to the animals, the specific animal objects version or value for height, we have to put this in front of it, and there we go. And now we can also do the same thing for weight and also name. Just change this to weight and change this to weight. And we could have also come up here and used this here. See how we had to use centimeters instead of having height or weight or whatever inside of there? If we would have used this, we would have been able to get around that. Just a way to refer so that the code actually knows what you're trying to code or what you're trying to do. You can also come in here and change that static variable. Remember, we are creating or changing the values here. And then once again, we're basically going to do this with the constructor as well.